This is going to be a quick video on how I put together a constant load, mostly from scrap parts I had lying around. A constant load is a device that always pulls the same amount of current, no matter how many volts are pushing on it. I'm not going to go too into detail here, but if you want to build this circuit yourself, you can go ahead and follow this diagram. The reason why there's so many resistors on the bottom right side is because that's what I had. I just salvaged them out of some old TVs, and that's what works for me. So this is how it looks after wiring everything together, and it seems to work too, which is kind of nice. Those are the white resistors that I salvaged out of an old television. Let's check it out with the thermal camera. I have a current limiting resistor in series with the fan mounted on the heatsink to prevent it from spinning so fast. And I noticed it was at about 85 degrees, which I think is too hot. So I decided to add another resistor in series with it to distribute the load, and there they are. It lowered the temperature by about 8 degrees. Here's the temperature after pushing about 2 amps through the system for a couple of minutes. The resistors I modified are at 83 degrees, the transistors at 28 degrees, and the white resistors that will dissipate most of the heat are at 39. So I think everything is good enough to put inside of an enclosure because the fan will keep everything nice and cool. I designed the enclosure using Onshape, which is a cloud-based 3D modeling platform. This side will hold the heatsink and the transistor. It will be mounted on there with a couple of screws. That slot there will hold the main circuit board with the op-amp and all of its auxiliaries. That side will hold the big resistors, and the back with all the holes in it will allow for the exhaust air to exit the enclosure. Here's the model in the 3D slicer to show the infill pattern. The enclosure turned out pretty well. The only issue I had was that I designed it with too tight of tolerances. I could barely get the circuit board in there, it was so tight. But I managed to get it in there with enough force. And fortunately I didn't break anything, which is good. Now it's time to test it out now that I've put it in an enclosure. The circuit needs 12 volts to power the op-amp, so I'll plug it in there. I'm going to connect it onto my variable power supply, push some power through it, and make sure it doesn't melt because one of the wires could be crossing or touching something that it shouldn't. Now that I've plugged it in, I'm going to set the constant load to pull 2 amps from the power supply, and then I'm going to vary the voltage to see if it holds steady. It's not perfect, but it's good enough for what I'm going to do with it.